What's up, Fun Nation? I'm Emilio, and I'm out here at Regional Monterrey with team number 6017, Cyberius from Robotics Santa Catarina. Cyberius is a team that has built up a huge amount of momentum in the past couple of seasons, and I'm out here with Romina, Rene, Nicole, and Javier, who will tell us about how they will keep this momentum going, with a robot featuring a double-jointed arm mounted on an elevator and a plethora of custom-made parts. Find out about all of this and more right here on Behind the Bumpers.
This video on fun is brought to you by our viewers, supporters, members, and also in partnership with the following. AndyMark provides superior service with the reliability that teams expect. Check out their sport gearbox and ratchet sport options to their tried and true compliant wheels used by teams all over the world. From mechanical and electrical products to tools and hardware, head on over to andymark.com for your one-stop shop of high quality and affordable solutions. Osh Cut is a premier metal cutting service for first teams. No minimum order, options for same-day turnaround, guaranteed lead times, and instant online quotes. Osh Cut is offering first teams 50% off any future order up to $200 when you scan the QR code or go to funroboticsnetwork.com/OSHCUT. Just upload a 3D model or plot pattern to get started.
We'll kick things off with Romina, who will tell us about the team's elevator.
So the elevator is a two-stage elevator with a carriage in the middle. It is powered by a transmission of 2 seconds X60 with a reduction of 10:1. Then we also use this band so we can hold the carriage up, which is this thing, and that holds the arm. And then we also have 2 springs which help with the control and also help for carrying the carriage and all the weight that the arm has, as well as the carriage.
Next up is Rene, who will tell us about their arm and intake.
Okay, so now moving on to the arm and intake. It works with a double pivot arm, so double link. So we have our main arm here that rotates around this axis right here. It has a 28:1 reduction, and this one moves like this. And then for this second link, what we have is inside of the carriage of the elevator, we have another one exactly the same, also 28:1, that rotates this max spline. And we use a max spline instead of a shaft because the max spline can take mechanical stress better and it doesn't deform as easily. And it rotates it through a pulley, and the pulley goes all the way through over to this side where it rotates the arm. Finally, we have our intake. So we have an intake that grabs a coil from the inside out, and it basically, with this Kraken motor, it rotates this with a 2:1 reduction, and it grabs it like this. It just slides right in.
Fascinating stuff. Now, Nicole, could you tell us about how you've tackled climbing the deep cage?
So we use this climber. It's made by a harpoon. This harpoon has a system with 2 wings for it to climb. Basically, the deep cage comes through here and sticks in these little spaces, in these little round things, for us to be really climb. To make sure that we don't fall out of there, we use these rubber bands that makes a good grip on them, and we also use this type of grip thing. And then we have this elastic band that help us to carry out this climber for it to be easier for the drivers to climb up. We also have these Krakens which has up an entire total of 60 plus 60 in each side. These are connected by a hex tube that connects to this band that can help the climber to return to its position. Once we start the match, for it to not to be like something that makes obstruction, we change its position to a more horizontal, vertical manner.
Next up is Javier, who will tell us about how the team brought all of this together through code.
Well, when we started developing the code of this robot, we thought about the drivers and reducing human error as much as possible. That's why every subsystem, every mechanism receives information, receives feedback from multiple sensors across the robot. for the automation of the robot, we decided for the elevator to place itself on the levels that the driver prefers according to the button they click. At the start of the match, when the robot is enabled, this climber starts inside of the robot, but to free up some space, when the robot is enabled. When the robot is enabled, this climber gets out to free up some space, and the drivers decide where they want to place the crawl, or if they want to get one from the crawl station, and the arm that is on the other side automatically gets into a position that we have pre-programmed it for have better precision. We use duty cycle to be able to have more efficiency and be more constant in our robot, and to reduce the errors that a human could make. Now to talk a bit more about our automation in electronics. So every single mechanism comes with at least two different sensors. So for example, on this intake we have a time of flight sensor, which helps us detect when the crawl piece has been placed on top. Then for the arms, we have camcoders. They're on the other side of the robot, and they basically detect the rotations that they have done. And we also use the motors on an encoder to also calculate as a redundancy. Then for the elevator, same as the arm, it also has a camcorder, but it also has an inductive sensor. So in the bottom of the elevator, there's an inductive sensor that is connected to a candy, and that one helps to detect when the elevator has fully gone down. It triggers and sends a signal to our robot. We have under the robot electronics, so everything is from inside. This is done to protect our robot from external damage from coral and algae and stuff like that. It is also covered, so nothing can get in or out. And we have two VRMs. So this one is used to power this half of the robot's sensors and limelight, and this one is for the other sensors and limelight.
So for this robot, we used aluminum 60, 61, I believe so, and 70, 75. We also use polycarbonate to make the mechanisms, because it was the best way for us to cut it. All of these materials are cut in special CNCs, so I could tell that most of the robot is actually manufactured not by hand.
All right, team, thank you so much for taking the time to show off your robot to us. You've built a truly fascinating machine, and wish you all the best of luck this weekend and in the rest of the season. Thank you.
Thanks for watching. Don't forget to like, subscribe, and click the bell to stay up to date on future fun videos. Osh Cut is a premier metal cutting service for first teams. No minimum order, options for same-day turnaround, guaranteed lead times, and instant online quotes. Osh Cut is offering first teams 50% off any future order up to $200 when you scan the QR code or go to funroboticsnetwork.com/OSHCUT. Just upload a 3D model or flat pattern to get started. AndyMark provides superior service with the reliability that teams expect. Check out their sport gearbox and ratchet sport options to their tried and true compliant wheels used by teams all over the world. From mechanical and electrical products to tools and hardware, head on over to andymark.com for your one-stop shop of high quality and affordable solutions.